We're going to continue the specific latent heat. And in this tutorial, we're going to talk about the latent heat of vaporization. When a liquid substance is heated, at its boiling point, the substance boils and turns into vapor. The energy supplied is called latent heat of vaporization. It is the energy needed by the particles to break away from their neighboring particles in the liquid. If the substance in its gas state is cooled, it will condense at the same temperature as its boiling point. Latent heat is transferred to the surroundings as the substance condenses into a liquid and its particles form new bonds. The specific latent heat of vaporization LFV of a substance is the energy needed to change the state of 1 kilogram of the substance from liquid to vapor at its boiling point without changing its temperature. The unit of specific latent heat of vaporization is the joule per kilogram. If energy E is transferred to a liquid at its boiling point and mass m of the substance boils away without change in temperature, the specific latent heat of vaporization L is equal to energy E in joules over mass m in kilograms. To measure the latent heat of vaporization of water, we use a low voltage heater, like in the figure, to bring water in an insulated beaker to the boil. The joule meter reading and the top balance reading are then measured and then remeasured after a certain time, for example, 5 minutes. The energy supplied E is equal to the difference between the joule meter readings. The mass of water boiled away, M, is equal to the difference between the readings of the top and balance, and the specific latent heat of vaporization of water is L equal E over M.